and I will mostly talk about what have I done in the past year and what I plan to do. So I'm new in science communication, about to do something, but I heard a lot of things and learned a lot of new methods in how to communicate science from those names you already saw. That was Tiana and Sasha, like, you know, they have a branding name so far. So it was like colleague and me was in Prague last year, and we attend to one science communication workshop, and we learn a lot of things, and then I decide to do something, not only to organize these workshops and to do it myself. So I decide to use my knowledge about physics and to learn something else and to create one of the billions YouTube channels that you can find. So here it is. Accidentally, I saved my first video that I made, and here it is. My last one, I did it today, and I finished today. It was in 1:30, yeah, in the morning. So I will show you the boat, and I will show you my progress in 1 year. And again, accidentally, tomorrow will be exact 1 year that I have that YouTube channel, and my first post on YouTube was on 25th of August last year. So what happened? We were in Prague, and there are a lot of people talking about podcasts, YouTube, talking about blogs, talking about, you heard everything here, and they're very good lecturers. And their lectures are so motivating that you need to do something, you know. And when I come back, I try to find what to do. I didn't have Facebook, I didn't have Instagram, I didn't have any social, I was not member of any social network, and particularly not YouTube. So there was a problem for me. In spite I'm a professor, I'm teaching, I have a very good communication with my students, and I had no problem to be in front of 50 people, 100 people, but I have a problem to make a video where I'm on video. So my problem was solved when I found some software so I can make an experiment in physics. I can show to someone, and the only thing that you can get from me is my voice. So I try to make some video, and I have, when you start something, you need to say to yourself, why do you want to do it? Do you want to make money? Do you want to have a hobby? Do you want to feel good? Do you want to help someone? So you need, in a start, to have a goal. It's hard, and you will learn all your life how to do something. So when I came back, so it was in April or May last year, I made my first video. But you need to say to yourself, I want to do this, and particularly sharp thing that you want to do. My goal is, I found in that moment, I have found that my students in the first year, not in science, but in I don't know, technical engineering or something like that, have a problem to distinguish velocity and speed. So there is nothing similar in our languages. When you say in English, like velocity and speed, that's two kind of different things, But in our languages, you have just one word, and you have to use like vector to announce that it is different. That is different thing. So I decide to make a video explaining what is the difference between speed and velocity, and between two things that you say. I'm going from Tuzla to Neum, and how much kilometer is that? So there are different things like changing positions, and some other stuff. So I try to find some solutions how to do it. And the first thing I did it, and I have it here, so it's my first video. You can see it's 7th of June last year. So I had 2 months to find what can I do and how to make it. And it's horrible. The first step is horrible, but it still is first step. No, and you need to do it. So this is what it looked like my first video. So. And you're trying to show something. The resolution is bad and so on and so on. So it's really horrible, but it was really success for me. Okay. Okay, so you can see here that these are the names of the videos. And I was trying to be, so okay, I'm sorry, it will be advertising myself, and but that's the only thing I can say about how to communicate science. I can show you that it is a really hard job, and you never give up, Even today, after 1 year. It's not so success, but I'm sure that every physicist, in Bosnia, do have some knowledge about this channel, and we communicate, and I have a lot of comments, But do not have any time, do not think to give up, So these are the names of the videos I made, and after, if you remember, it's April. And the first video is the difference between displacement and distance, average velocity and average speed. That's my goal. That's what I want to achieve. And you saw the first video that I made. You will see some connection with this video, but this is improvement in 4 months or 5 months learning some software to use and to make a video. Okay, I will show you. So this is the final product. So it's really simple, It's really simple, but you need to learn something like where to put it, how to arrange something, to make color, to make vector, and I'm trying to know, like, this is a classroom, and these are tables, blackboards, and like you are writing with a chalk or something like that. But you have to realize that this is actually my first video posted on YouTube. And it was like almost 1 year ago. I try to explain in a simple way what is displacement I will not talking about displacement and the average velocity, of course. So I'm just trying to say you what have I done to do that. So I used a lot of things. I learned a lot of things. It's time consuming, but you know you will have something like, so you know, maybe something like this. Okay. After that, I have a lot of another videos using the same techniques, and this will show how to. This video shows some material point, as we say in English, moving in a 3D space, you know. And the thing that's really important here is to show students that you need to observe one 3D motion in three, two-dimensional motions. Okay, so this is for me. This was another step, where this is where I learned how to manipulate with objects in 3D space. And the final results here is somewhere. This is where you show moving point in one dimension or two dimension, and then like something like this. Okay. Okay. So this is where you have a motion in 3 dimension, but also there is a coordinate moving, whatever, x, y, and z. So it can be nice. So, okay. Sorry. Then, I make another breakthrough for me, when I learn how to make something like this, You made planets, it's always interesting. And this is where I talk about, warp speed. This is something really, really interesting for all of us, And I realized that we will have a problem, like Mythbusters. Someone mentioned it. Can you see something like this? That's the problem for me. And I have an explanation that, in our system of references, even when you include some relativistic effects, it's really a problem to see something like this. I will be short, just imagine 2 stars, and the near stars, and the average distance between 2 stars is like 4 light years. Okay, so if you travel by light, by speed of light, you need 4 years to reach 1 star. So how can stars or starship goes how much? So what the speed of the starship need to be that the stars travels like this in this point? So that's a problem, And this is like 100 C. This is warp 3. This is information. So warp 3 is like 1,000 C, 1,000 times faster than the light, So that's and you in Star Trek you can see warp 7 like very easily. Let's go. Okay, so but the warp speed, of course, is something else. Warp speed is when you're deforming the space itself. So it can be functional, but with some other, explanation or hypothesis or something like that. So okay, So that was a really breakthrough to me, and you know, I didn't say what's my goal, you know, in first place. So that here is time to say what I want to achieve, you know. Always I want to make a SF movie. That was my desire, you know. You know, I think everybody here, almost everybody, likes SF movies. So that's the for me, that's the best movie that I can see. Even you know, you know, they say B production or C production. I saw everything. You know, I just like to watch that movie. So I'm trying to make a movie about, you know, maybe so insignificant matters like differences between displacement and, you know, distance average velocity. So no one cares. But for me, as a teacher, it is the most important thing that you need to learn, to give the knowledge to the students. Because the most important thing that you can learn someone is how much is 2 plus 2. That's the basic. If you do not know the answer for that question, you will have a problem. If you do not know, like a physicist, the answer, what is the difference between displacement and distance, you cannot go from kinematics to any other places in physics. Really, you need to know the basic things. You need to realize in your head what it is in the proper way. So, okay, then I was trying to learn, you know, how to implement some kind of SF effects in my video. Still, I'm not in my videos, but for sure, maybe next 2 or 3 months, I will be there. And I will have some gadgets in my hands, like you can see in science fiction movies, and that will be my goal. When I learn it, I will show you.
Sorry, real you or a hologram?
Yeah, real me, but with the holograms, with some gadgets in my hands, and explaining so insignificant things in physics. For me, very, very important. So, those first videos were in English, and then you know, it's easier for everybody else here, I'm supposed to speak in our languages, and it's easy if you can communicate with others, have a problem. So, I made my first visual effects here. First visual effects here, and really a good breakthrough for me. So just one thing. Before that, I had I don't know, 100 working hours to make something that looks real. You know, it's animated, but it's, for me, it looks real. That's the video before that. It's satellites and what is needed to send them in the orbits. Like a question, like for general publics to know. This is simple things for physicists, you know. You will learn it on first year or something like that, but it is interesting for someone else. Okay, so I'm just let me show you what it looks like, and I need to mention that everything here is I made it myself, you know, like sun, like Earth, like moon, and we are talking about, you know, satellites. That's the word, satellite, moon is satellite. But also I I would like to show some, our satellite, so handmade satellite. So this is a story. If you want to look, please, you will see over here the context of this video. And then, just I'm very proud of this video. So yeah, and you can see where is going. So it's real sky. It's real stars. It's not just it's our sky. So it's Elon Musk's pictures or something like that. Yeah, and here it starts to explain how do you make satellite going around the Earth. And this is what it's so exhausting, but it's it gives you a pleasure when you finish it and when you show something like this. Someone who wants to listen. So of course, in addition, I show the movement of the satellite from other perspective. This is how the satellite actually goes when you see from some different points. And of course, I have made a lot of comments, and I have got a lot of comments when I mentioned, of course, what if the Earth is flat, or and this is a part for flat earthers. I don't know how to say it. And I show how satellite will be moving, and I mentioned quantum mechanics. Why not? So just let me one more step. So the satellite shows over there, and disappeared here, and again shows over there. So it's you can explain it with quantum mechanics, something like that. So, and this is basic black hole.
But it enters the wormhole at the end,
Yeah, of course. Okay.
If you can't explain it.
And then of course I made our what time is it, please? One is pet. Okay. I made it my first visual effect. So this is something that you make a movie. This is my working space, and then I put some animated things. I'm sorry. So it's okay. I will stop it somewhere here. So this is monkey head, like just put it over there. This is sheet of paper, and this is, of course, this is effect. This you can see the shadow. So you can move it like realistic thing, but you can do whatever you want. And I did it. I did it a lot of things with this SF or VFX. And then goes another one. Okay. So when I say another one, so it's really short videos. When I was showing you something that you hold in your hands, and you put it there, and you can put your nose. I saw my daughters once like to, and this is one of the, like I tried to make an intro to general physics channel, and it's just a game. I'm trying to game the letters and waves and something like that. Yeah. In the end, it will be revealed. Okay, general physics problems and solutions. So okay, and just another one. Of course, let me. Okay. So it's right. Okay, and this is where so this is, the name is, everybody understands, so, okay. But this is where I, applied everything I know. It is a table where I work, and this is differences between this kind of material, this kind of material. So why do you feel like in your bedroom when you stay on the, I don't know how to say plastic. Really? Why is it colder than when you stay on the wool? It's not colder. It's just different material, and it's your feel. They are on the same temperature. So you can see this planet. It was on the first video. So you just copy and paste in your in this video, but you need to make. This was some like metaball or something like that, and they are moving. But also you can use this program, there's some exchange of temperature, like you visualize to exchange some temperature. So temperature goes from body with hot to the colder one. This just you exchange it to reels and something like that, and of course, you can see these pedals also like monitor or something like that, and you can use it. You can use some materials, different materials, of course, but of course you can simulate very easily something. So just find. Okay, you can simulate the water. It consumes your memory, computer memory or something like that. But you can simulate a water, a smoke, a fire, or something like that. And this is what can you use to explain someone the most basic things in physics. And you need to have some idea, imagination, and to spend a lot of time, but when you made it once, you can use it whenever you want. Yes, I made it for my classes and so on and so on. So, my last video was made using some SF, things, and I will show you my last video from it's 1:30 in the morning that I finish it. So this will be the last thing I want to show you. Okay, so be prepared. There is no sound, of course. You need to watch it maybe several times to figure out what's going on. So, but it's really easy to do it. If you have, I mean, I just made I didn't plan to do it, but when I saw it, it's I don't know what you are showing. Where to stay or something like that, I don't know. And that's just, yeah. And you can do it a lot of things. So it's I need to make it. So it's to give you a name. It's Blender. The software. It's really powerful, and a lot of animation movies, like in Hollywood movies, made it in this Blender. And what is important is that it's free. It's free, and you can use it. And there is a lot of YouTube tutorials for this Blender, and this is something that we all, or I don't know, can use or should use. But it can be done like with one person, or it's you need a team to work with someone if you want to have something serious. And just one more thing before we finish, I would like to ask Rifat to tell us what we have done in Tuzla to promote our faculty, our staff, and to promote physics and to get more and more students.